Hello, and welcome to this edition of Tech Talk. My name is Eddie Ambler, and my co-host is.
And I'm Leo Alvarado.
Today, we have an exciting agenda for you. We're going to be discussing the top 6 Oracle Database Cloud Service features that you might have missed that came out in 2023. As you can see by the agenda, we'll begin by discussing the Oracle Converged database so that everyone gets a good understanding of all the great features and capabilities that are included inside of the database. We'll then transition to a discussion about the available Oracle Database Cloud services. To wrap that up, we'll then dig into those top 6 Oracle Database Cloud Service features that we want to discuss, starting with automatic backups with autonomous recovery service. We'll then discuss how to create a database from a backup across availability domains within the same region. We'll then discuss backup and restoring capabilities from a standby database. And there are a ton of enhancements that came out with PDB management, so we'll dig right into those features and functions and show you how they can be used to solve some of the challenges you've been having. We'll then transition to discussing about Elastic Pool resources so that you can understand all of the ways that cloud automation and cloud services are being enhanced to be able to better service small and mid-sized workloads and consolidation initiatives. And at the end, we'll wrap up with introducing you to the Exadata Fleet Update. With that, let's get started. The Oracle database is an all-inclusive and converged by design. As you can see on the screen, it has a ton of data models available, such as spatial, graph, blockchain, JSON. It's suitable for data science, analytics, OLTP transactions, IoT, and all types of low-code application development, all under one engine, one umbrella, making it very simple for developers to develop applications that might have different types of data needs. So simplifying the development lifecycle actually improves your time to market and reduces the amount of coding and labor required. So what is inside the Oracle Converged database? This gives you a great visual of all the things we were just talking about. Whether you need to store XML data, document data, spatial geometry data, or just relational data, as most of us have been doing, or if you're wanting to work with JSON natively, the Oracle Converged database has the ability to concurrently allow you to access your data in SQL and JSON format. It also has the ability to provide you with immutable capabilities such as blockchain tables and enhance your analytic processes with in-memory analytics. Being able to help your analytics teams be able to deduce information out of the data by applying graph technology to the data sets. The Converged Oracle database is also available everywhere. Doesn't matter whether you're trying to run your workload on-premise, on commodity hardware, on our engineered systems, in the cloud, in Oracle's cloud, in a third-party cloud, or if your workloads are containerized, or even if you need to bring Oracle's cloud solution behind your data center in our cloud customer offering, Oracle Converged database is able to run everywhere. So where is Oracle Cloud available? As you can see, Oracle has been working diligently to increase its footprint and make the resources required to be able to deliver the maximum availability architecture across the globe. Oracle has been partnering with Azure to have co-managed environments in which the data centers are there that provide services for both Oracle and Azure to make it easier for our customers to be able to do multi-cloud deployments, getting the best services from the best cloud vendors. So let's take a quick look at cloud management responsibilities for the Oracle Cloud Database Solutions. The cloud offers 3 layers of different offerings. You can have a customer managed solution that runs on IaaS, in which the customer is expected to manage everything above the hypervisor. The cloud provider provides you the infrastructure and you do the rest, to a PaaS, which is depicted here in the middle with Oracle's base database and Exadata database service, in which Oracle also provides you with the installation of the Oracle software and provides you the automation that's required to do everything above the hypervisor, including applying patches, backup and restore, conduct change management, and be alerted on things like incident management as well. And finally, there is also database as a service. For those who need a fully managed service, the cloud providers provide that kind of stack that allows the cloud provider to manage everything up to the data stack in which the customer focuses on managing the application data and not the infrastructure and the environment. So now that I've kind of outlined what we are, let's just briefly review the available Oracle Database Cloud services. You can run the Oracle Database Cloud services in the Oracle Public Cloud or in your customer data center. So in the Oracle Public Cloud, as I mentioned, you have 3 services that are available for running the Oracle Cloud Database. We have our base database service, which runs on our VM systems, can run single instance, 2-node rack, up to 80 terabytes of database storage is available in this configuration. When you need a little bit more size, scale, processing power, this is where the Exadata database service on dedicated infrastructure service comes into play. Using the same Exadata infrastructure as you would have on premise, but giving it to you with cloud automation services and the cloud economics and scale. For those customers who need a fully managed database service, this is where our autonomous database on shared or dedicated Exadata infrastructure services come to play, right? You're able to, again, get a fully managed database service that runs on the Exadata platform in either a dedicated infrastructure or as part of our shared infrastructure. One really critical point here that really adds value to the Oracle Public Cloud is that there is no minimum term for infrastructure, right? 48 hours is the minimum in time that you have to run it. And as far as the OCPUs, Cloud Economics allows you to increase and decrease the OCPUs as required. For those customers who need to be able to run the database platform behind their firewall to meet regulatory or compliance reasons, or maybe it's just latency reasons between applications that are going to remain on-premise, but you want to start moving to the cloud. This is where we have our Cloud at Customer offerings. Again, you can have the co-managed approach with our Exadata database service on Cloud at Customer, in which Oracle manages the infrastructure and the customers manages the guest VM OS, which includes the grid infrastructure and database homes, or they can take it as a fully managed service, again, using our autonomous database on Exadata Cloud at Customer. So let's take a look at how easy it is to navigate and use these services. We'll click on the hamburger menu, then select Oracle Database. Then in the bottom here, in step 3, you'll see the available Oracle Database services that we just outlined. You'll simply select the Oracle Database service that you'd like to administer, and it will take you to those details page, as you'll see in our demos. So let's get to the meat of why we're here today. Let's discuss the top 6 database cloud services that you might have missed in 2023. We'll start with the automatic backups and autonomous recovery service. So what are some of the pains that we were trying to solve with the autonomous recovery service, right? Our customers, they wanted to automate Armin configurations and jobs, and they wanted to ensure that their deployments and backup jobs were using best practices. We also had customers who were looking for a way to simplify and automate the Armin restore jobs, and they wanted to eliminate the need for manual Armin scripting. They also wanted visibility into the state of the recoverability of their database. They needed real-time protection of transactions to try and reduce data loss. And ultimately, they also wanted the ability to safeguard their backups against deletion or tampering. Well, what were the target solutions for this? This is where the autonomous recovery service and its features came in. So during the next few slides, we'll introduce you to this feature and service and also demonstrate how to use it. But before I start with that, let me introduce you to the Zero Data Loss Recovery Appliance, which is the engineered systems for backing up databases that's available on premise. So the ZDLRA is a very different architecture. It uses space-efficient virtual full backups. What does this mean? No more full backup. It's an incremental forever architecture. After the one-time initial full backups, incrementals are used to create virtual full database backups on a daily basis. Virtual backups typically take 10 times less space to execute. This enables long backup history to be kept with the smallest possible space consumption. Think of this as a time machine for the database. So on day 0, you can see in the diagram, all the blocks are blue. On day 1, only the blocks that are been changed are stored in the recovery service, which are depicted here as red blocks. At the end of the day, a virtual full of this map is made. This allows you to be able to do a point-in-time recovery without needing to do the incremental applies. And as you all know, that will save you hours and hours of time, as it's the serial process of the incremental applies that often slows down our restores. As the additional days go, the same activity happens. Only the incremental blocks are stored in the recovery appliance. And again, every night, that night's virtual full is created for use in your recovery in the future. Okay, so what does this look like when you put it all together? You can see that the day that you pick, the map will be built for your virtual full, where the blue blocks are the original blocks and the red blocks are the change blocks. And that will be pushed back to you as a virtual full for your restore. So this is a very optimized architecture, as it's only pushing the changes from your database to the recovery appliance. So what does this mean in terms of the public cloud? So for the public cloud, this is where we have introduced the autonomous recovery service, which is based on that same architecture we just went over. So in the public cloud, you have the ability to use either the autonomous recovery storage, object storage, and if you've configured your Exadata infrastructure for local storage backups, you can use that as an option as well. So now let's dig into the ZDLRA recovery service. The recovery service allows OCI customers to automate backups and enables immutability. Backups are stored outside of the customer's tenancy, which allows them to safeguard against deletion or tampering by admins. It also provides endpoints for connectivity, establishing secure communications between the recovery service and the database, providing an air gap between your backup data and your actual database. The Armin configurations and jobs are automated, ensuring best practices and the ability to monitor the state of your recoverability. Backups are always replicated to another AD, providing you with high availability for your backups. You can optionally use real-time protection to help reduce any data loss. Simple automated Armin restore eliminates manual Armin scripting and DB scheduling. So you will see how much simplified the Armin restore process is during our demos. So let's take our first demo, which is creating a database with automatic backups using the autonomous recovery service. So we'd start by clicking on the hamburger menu, then selecting Oracle Database, then selecting the database service that we want to work on. In this case, we're going to work on Exadata, go to our VM cluster, select the VM cluster where our database lives. We're going to click Create Database, provide the basic information for our database, such as its name, the image version of the database that we want to run. Then we'll specify whether or not we want to create a new database home or use an existing database home. And finally, we'll provide the admin passwords that we should use for our database. Now, in the backup section, we will choose whether or not we want to use the autonomous recovery service or the object storage. It is recommended to use the autonomous recovery service, as this has the same cost point of using object storage with way more benefits to be offered. As part of the autonomous recovery service, it uses policies to be able to ensure that the databases all are recovered with the expected policies. As you can see, there are a set of default policies available for you to choose from, but you can customize policies that define things such as the retention period and the recovery windows. If you choose not to do a backup the initial backup of your database right away as you're creating it, it's okay. You're able to zoom in here and pick the schedule of the day and the time that you want to choose for your initial backup. You can also select a time of day that you like your incrementals to happen. And in the event that you delete a database, you can also define things like what is the retention policy that you want to have for deleted databases? What do you want to happen for those backups? Do you want to retain them for the retention policy duration or for 72 hours before they're deleted? I mentioned the ability to be able to create a backup solution that guarantees zero data loss. This is an enhanced service that has a cost associated to it that's called real-time data protection that allows the redo stream to be streamed directly to the autonomous recovery service, providing you with that type of feature. Well, once you click on Create Database, you'll see that your database starts provisioning and that you get a status of in progress for the state. Once the provisioning of the database is done, you'll see that it gets a state of available, and the backup section of the details page shows you that its destination is indeed the autonomous recovery service, that we did not choose to implement real-time data protection at this point, and that we applied the protection policy of Silver to cover this database. If you did not choose to actually configure your automatic backups while you were creating the database, no problem. After the database has provisioned, you can simply click on Configure Automatic Backups and enter the same information that we just went through and click on Save and Changes, and your backups will be automatically done. Thank you very much for paying attention to this demo. So Leo, over to you for this feature.
Thanks, Eddie. So for the second feature, it's the let's go now to the create database from backup. But before we proceed, let's start with the common challenge that our customers are sharing with us and that we try to address with this new enhancement feature. So there's a challenge or a need to provide the ability to create a database in another availability domain or AD within the same region, which can be different from the availability domain where the backup was taken. So for the target solution, we will be covering creating a database from backup and conducting backup from a backup on primary or a standby database. Now let's start with the create a database from backup across availability domain. So creating database from backup feature, that is not new. It's been there for quite some time now. Like from the list of available automatic backups and on-demand full backups, you can easily create a database. Now, what we are discussing here is the enhancement. So with this enhancement, when an availability domain is up, so you can create a database from a backup either within the same availability domain or in a different availability domain within the same region. And that this feature is available for both Oracle Exadata database service on dedicated infrastructure and Oracle-based database service. And this feature also is available regardless whether the backup was created from the with the backup destination using OCI object storage or autonomous recovery service, and that you can restore a backup taken on either a database that was configured using the host-based wallets or the local wallet or OCI Vault. Now let's see how easy it is to create a database from backup using the console. So from your database details page under the More Actions tab, so you can just click on Create database from the latest backup, or alternatively, from the list of your available backups, you can click on the action icon and then click Create database. So as you click Create database from backup, you have an options whether to include all the PDBs or choose the PDBs that you want to restore. And then when you click on Next, here you'll see that it will show you where your source backup is currently running, which it shows it's 81, and that you can choose a different 80 to create the database from your backup, and that you need to provide the basic info for Exadata infrastructure, like you need to choose the Exadata cloud infrastructure and then the VM cluster, and then if you click on next, you'll just need to fill in the required database details, and that's it. So you can click on create database. So that's how easy it is using the cloud automation tools. So what I have covered is within the same region. Now, if you wanted to do like cross region, I'll be calling out Eddie to help us out in covering that. Over to you, Eddie.
Thank you very much, Leo. We've talked about the recovery service and how it simplifies doing automatic backups. Now let's look at backup and restore from a standby database. So, what are the challenges and pains that in this area that customers were having and we're trying to solve? Is customers had a need to offload the backup task from the primary database so that backups weren't impacting the CPU of their production workloads. They also had a need to restore or recover standby database to a point in time. Maybe they needed to, back out some logical errors or look at the data at a particular point in time. Now, this feature will give them the ability to be able to recover a standby back to a point in time using the backup from the standby. Or if they simply just wanted to create a copy of the database from the backup in another region, this is a great way that they can do that, right? So you can actually create your data guard in another region and enable that standby with a backup. And now you'll have a backup that's in that region that you can use. So let's take a look at how we would actually enable a backup on a standby. As you can see, we'd start our navigation by clicking on the hamburger menu, then Oracle Database. Then we will actually click on the database service that we want to initiate. We'll then select our database that we want to create the backup for. In this case, we select our database here, and we can see that our database is MyCDB01, and that this version of MyCDB01 is our primary database. And if you look at the bottom here, you will see that it has a data guard peer that is also called MyCDB01 that has a peer role of standby. So if we click on that, it'll bring us over to that database. As you can see here on the left side and under general information, it has a role of standby. Click configure automatic backups. And here we simply will check the mark that says enable automatic backups, select the backup destination that we want, whether it's object storage or recovery service. In this case, we picked object storage, so we get to select the backup retention period, same details as to what to do with the backups if the database is deleted, and we're able to provide the schedule for the full backups that we want, which day of the week, what time of the day, and also provide a schedule for the incremental backups. And more importantly, we can also then check the checkbox that says, I not only want to configure these details for the backup, but I'd like to take this first backup immediately. Those are all options that you can do. You click Save Changes, and that's it. You're done. Automatic backups are configured. So we've made it very, very simple with just a few clicks to have this. You can see that your standby now has a backup detail that shows enabled. It tells you when the last backup was completed, when the next backup is scheduled, and it'll tell you what the backup destination. As you can see here, we chose object storage, and we chose a backup retention period of 7 days. So without needing to do a whole bunch of commands and queries, we can just simply come to the database details page for the standby and see what the backup configurations are. Thank you very much for watching this demo. Now let's look at restore from standby, right? So we just went over how to configure the standby for backups. This time around, we're going to look at how to use those backups to do a restore. So we'll navigate to our database again. Okay, clicking again on my base DB, going into the database. So we're on the primary database. We click its peer standby. And as you can see here, now we're on the standby. Okay, so if you just click on restore function in the details tab, we'll be able to actually choose whether we want to restore to the latest, restore to a timestamp, or restore to an SCN. And for our demo, we just picked restore to the latest. This actually puts the standby database in an update mode while this operation happens. Okay, when it's done, you'll see it actually change to the state of available. And if you look at the work request, you can see at the bottom that it shows you that the restore database operation was successful. Thank you very much for watching this demo. So now reached a really cool segment. Leo, can you walk us through enhancements to PDB management?
All right, Eddie, before we start, let's go to the common challenges in terms of the PDB management. So there's a challenge or there's a need to take an immediate backup of a pluggable database. And most of our customers, they also mention about the challenge and that they need to restore a PDB within the same CDB or to a new CDB. Another challenge is there's a need to create a copy of that pluggable database within the same CDB or to a different CDB. And then another challenge is they need the ability to create a refreshable copy of a PDB. And lastly is that they mention about a need to move the PDB to another CDB where the destination CDB can be in a different compartment or VM cluster or DB system. So let's look at the enhancement feature offerings or the target solutions. So the new set of enhancements bring the automation via the OCI UI or API for the following pluggable database specific features. And these are available across our database cloud services. So for base database service, for Exadata database service, both for on dedicated infrastructure and on cloud and customer. And with these enhancements, it helps you leverage new PDB automation capabilities for end-to-end application development and deployment to the cloud. So let's see one by one. So let's start with the how you create a PDB backup. So just to show you a quick navigation. So from the VM clusters that host your container database, so you just need to choose the container database in which your PDB resides. So in here, it's my exadb, so that's our container database, and inside your container database details page, under the resources, you'll see the pluggable databases there. So when you click on create a pluggable database, you'll see that there's an option for you, or when you create a PDB, you can already specify if you would like to take an immediate backup of your PDB. Now let's move on the restore PDB. So from your PDB details page, or you can restore a PDB within the same CDB or to a new CDB. Now, when you click on restore, so it gives you the option to choose whether you wanted to restore it between the latest or a specified timestamp. Then the other enhancement is how you can create a database from from a backup. So the create database from backup, it's enhanced now to allow a restore of a PDB or a set of PDBs on a new CDB. So here you can see that you can specify a PDB or a group of pluggable databases by choosing the choose the PDBs to restore option. Now let's go to the remote clone. So how easy for you to do the clone? So in the PDB details page, you click on the clone icon, so you can create a copy of the PDB within the same CDB or different CDB. The destination container database can be of the same database version or higher. You have an option to provide an existing common username that the database link will connect to. And there's also an option for you to take the backup of that pluggable database after the remote cloning. Now, when it comes to the refreshable clone, so you can create a refreshable copy of your pluggable database by choosing the refreshable clone option. And that same thing. So on the next slide, you'll see that you can also provide a common username, which is mandatory for your data link connection. And then on the second slide, you'll see that a refreshable clone PDB can be refreshed by going to the More Actions tab and then initiating the action refresh for you to be able to refresh successfully depending on the availability of the archive or redo log files. Then to disconnect the refreshable clone pluggable database from the source, you can also convert it to a regular PDB. So once converted, the PDB will be opened, read write, and all the lifecycle operations can be performed. And then you'll see here that there's also an option for you to take the backup or to take a backup of the pluggable database after converting it from a refreshable clone to a regular PDB. Now, when it comes to relocating, so you can move a pluggable database to another container database, then the destination container database can be in different compartment, VM cluster, or DB system. So your destination container database can be in the same database version or higher, and then you can provide a new PDB name while relocating a PDB to a different CDB. Then optionally, again, you can also provide a common username to for the database link that will connect to, and there's also an option for you to back up the pluggable database after relocating it to a new destination container database. So that's how easy it is in terms of the automation tools in the UI. Over to you, Eddie.
Thank you for that, Leo. Those are some really, really good enhancements. Should give our customers the flexibility they need to be able to do anything. Well, this next topic was really exciting to me as it really shows how cloud automation and our cloud database services is making the Oracle database affordable and available for all sizes of workloads. The autonomous database has a feature called Elastic Resource Pool that I wanted to share with the team so that they were aware of this great feature that could not only simplify consolidation, but really save the customers a lot of money. So let's talk about it. What is an elastic resource pool? An elastic pool is a collection of databases grouped together for pricing efficiency, right? It allows for oversubscription and fractional eCPU realization. Customers are charged only for the uses of the entire pool rather than each individual's database's allocation. The total number of eCPUs that are provisioned in a resource pool can be up to 4 times the pool size. And I'll walk you through some examples of what pool sizes are and how eCPUs are billed in a moment. You'll only pay for the active eCPUs in the pool, regardless of how many ADB databases are deployed. The available pool sizes range from 128 all the way to 4,096 eCPU. You can scale your individual database eCPUs up or down as required and add or remove databases from your pool as you need to. This provides a 4x to 8x cost savings, as we will go through examples of how this is possible. So this adds up to benefits of up to 87% cost savings. Now, who wouldn't want to bring that kind of technology into their organization? So you no longer have to search for other solutions other than the Oracle database simply based on cost. This solution makes it very, very affordable to run many databases and many small databases at a very affordable price point. On-prem customers who migrate from oversubscribed database systems will find a lot of benefits using this feature. Customers with large numbers of very small databases, such as maybe microservice architectures, would find benefits in this feature. SaaS providers with high numbers of databases would also benefit from this feature. And also databases that are periodically used. Maybe you have some dev or test or QA databases that you don't really use that much. These are great candidates to use elastic resource pools for. So let's take a look at the cost comparison, right? Let's say we were provisioning 512 databases with and without resource pools and see what that looks like. So without the elastic resource pool, we would have 512 autonomous databases being provisioned with 2 eCPUs each. That means that we would expect a bill for 1,024 eCPUs. But with elastic resource pools, we can get the same level of consolidation, but lower the cost, okay? Especially if we're saying that all of our databases aren't always active, right? Or that our databases only need occasional CPU resources. This allows us to take those 512 databases and apply maybe 1 eCPU to each and use a pool size of 128. You might say, well, wait a minute. If the pool size is 120 eCPU, how can I deploy 512 databases with 1 eCPU? Well, that's because remember that you can provision your databases with up to 4 times the pool size. So this would give us an expected cost of 128 eCPUs if only 25% of our databases were active at any point in time. And I'm going to walk you through an example of how billing would move as the concurrent use of the databases moves. So let's take a look at this chart of our consolidation environment, right, of our 512 databases with a pool size of 128 CPUs. So at noon to 8 a.m., the peak eCPU utilization of the pool is 50 eCPUs. So what does that mean for our bill? You will be billed for the 128 eCPUs. So the minimum bill that you would expect is your pool size, and the maximum bill you would expect is 4 times your pool size. So let's keep looking. So what if the peak eCPUs from 8 to 9 a.m. were 140 eCPUs? In this case, you would be billed for 256 eCPUs. So what happens if the eCPU utilization from 9 to 12 is 90 eCPUs? Again, even though it's less than 128, you would pay the pool size amount, which is 128. Well, what about if the peak eCPU utilization is 300 eCPUs? Then you would be billed at 512 eCPUs. Why? Because your usage falls between the ranges of 256 and the next tier, which is 512. And lastly, we'll look at one last example. Again, if your peak eCPU utilization from 1 p.m. to 12 a.m. the next day, it was 112, then you'd be billed at the 128. So as you can see, as your workloads change over time, your billed eCPU will flex, but you are able to constantly save money by using the elastic resource pool methodology. So let's take a quick look at how to create a resource pool during database provisioning. You know, as you can see, when you create a resource pool during provisioning, there is one requirement that that database be an autonomous transaction processing database, right? In the create database, configure database screen, you would have a checkbox that says enable resource pool. And for the pool eCPU count, you simply select the pool size that you would like, and it would be created for you. What if you've already created your autonomous transaction processing database and you've then decided that you wanted to create an elastic resource pool? Not an issue. You simply click on Manage Resource Allocation and then select Enable Resource Pool, select the pool size that you want, save changes. What if you already have a database that already exists and you'd like to join an existing resource pool? Not an issue at all. You simply, in the configure database section, you say enable resource pool, and then you select the pool leader from the drop down of available resource pools. You can also join an existing resource pool after your database has been provisioned. Okay, you again click Manage Resource Allocation, enable the resource pool, select to join an existing resource pool, and from the available pool leaders, select the pool leader name that you want. Select Apply, and you're done. So hopefully you could see that that was a very simple way to actually really lower your eCPU costs by using the elastic resource pools. So have fun with the feature and good luck. Leo?
Yeah, thanks Eddie for that great demo and discussion. So from the Elastic resource pools, now we move to Exadata fleet update. So let's start with what problem does Exadata fleet update solve, like, and why do you need to care about it? So in terms of simplifying maintenance, so there's a challenge on how you automate uh, operations updates for large scale database deployments to group of databases and grid infrastructures in a single maintenance schedule and cycle. And then when it comes to saving time on administration, so currently all patching operations are considered point operations, and that meaning one, it's just doing one target at a time, and that if you have multiple target to maintain. So this means a lot of screens and a lot of click of operations to perform. And there's also a challenge to maintain the scripts, especially if you're doing a lot of scripting in terms of doing your maintenance updates. So with the Exadata fleet update, so what we are announcing here. So the Exadata fleet update, so it simplifies, standardizes, automates, and enhances the Oracle database and grid infrastructure patching experience. So it helps automates the maintenance for operations for large scale database deployments for both Exadata database service on dedicated infrastructure and Exadata database service on cloud at customer. And then you'll see here it's a full native OCI service. And then in terms of the available or choice of interface, so you can do it via the OCI console, via the API, or via the command line. And what's good it is it's available free of charge when you're subscribed to Oracle Exadata database service on dedicated infrastructure or Exadata database service on cloud at customer. So how does Exadata fleet update work? Conceptually, Exadata fleet update, it's very straightforward. It's just a two-step process. So you just need to define a collection based on a search criteria. This is, you can create a collection just for your databases, or you can create a collection just for your grid infrastructure. And then second is to define the maintenance cycle. And then after which you can already start the patching process. And by grouping targets in what we call collections, and then applying maintenance cycles on the collection, we can now apply the updates in as a single entity instead of an individual targets. So the things that you need to remember of, like targets can be a database or grid infrastructure, and then targets can span on multiple infrastructure of the same Exadata cloud service type. Now let's see how easy it is to create a collection. So from the OCI console, click on Oracle database and click on Exadata fleet update. And there you can see under the collections tab, click on create collection. Then you'll see here that you can create a collection out of a collection type, whether it's database or grid infrastructure. And then you just need to on the next page, you just need to specify which cloud service are you creating the collection, whether it's for the Exadata database service and dedicated or cloud customer. And then you just need to specify the current version. And then when you click on next, that's where you will do the and add the search criteria. So for the search criteria, you can search for the databases that's running on certain release update. So for this demo, we will try to create a collection for all the databases running on 19.19. And then after you choose the version on the next page, you'll see that you can specify the Exadata infrastructure, the VM cluster. You can also apply filters like a wildcard. Like I just wanted to display all my databases with my Exa wildcard. And then after that, you can apply the search criteria. So after applying the search criteria, you'll see that it tries to search for the collections based on the criteria that you have provided. And once the results are available, you can easily pick and choose which one you want to include on your collection. So here is a sample, like we're just including all the 19.19 databases in our collection, and then click on create collection. So after you have created the uh, collection, you'll now see the collection type, which is a database, the cloud service, and then the current version. So now after you created the collection, now let's move to maintenance cycle. So what's a maintenance cycle? So simply a maintenance cycle defines the what and the how. So this is where you define the required, or that's your target version, standard release updates, or even custom image. You can also define here the how, like the maintenance method, whether you wanted to do rolling or non-rolling maintenance method. You can also specify the drain timeout and other options. So that's the maintenance cycle. Now, how does a maintenance cycle work? So the maintenance cycle process consists of several phases, and all those phases can be scheduled. So you'll see here that you can start with a pre-check and then staging the software to make the updates available, and then you can do another pre-check before applying the actual updates to your uh, target. And most of these steps will create a job associated on a work request per target in the collection with corresponding logs. And then the logs makes it easier for you to uh, troubleshoot the maintenance action. Now let's see how easy it is for you to create the maintenance cycle. So from your DB collection under the resources, just click on the maintenance cycles and click create maintenance cycle. Then you can choose your target database version, which we are updating 19.19.19 to 19.22. You also have an option to choose whether you want to create a new database home or use an existing one, and also to define your maintenance method. So for this demo, we will be defining a rolling patching, but you can also choose whether 50/50 rolling, non-rolling, or smart batch will gives you the option to choose the order of the nodes for the maintenance cycle. Then once you've uh, have those information, you can also set the schedule for the stage update and apply update. So once everything is set, you can just need to click on create maintenance cycle. Then once the maintenance cycle is created, so you'll see here the target database version for the update, which is 19.22. And then for the policy, it will be creating a new DB home for your defined collection, which is the MyDB collection, which are all your database running on 19.19. And then next, we'll be showing you how you will do the actual update. So you'll see it from your maintenance cycle. So you'll see the different actions there. So you can easily run a pre-check, the staging of the software, or applying the updates. And as best practice, it is recommended, of course, to run a pre-check prior to each of the maintenance actions, like staging software and applying of updates. So that's how easy it is for you to do and perform your Exadata fleet update with this feature.
Thank you for that, Leo. That's pretty amazing. So with Fleet Update, it really does give customers the flexibility to manage many as a single operation, right? They can do the planning, group their infrastructure, group their environments into logical groups, and then execute on them as they need to. So this should get a lot of use out in the field. I think we've been answering the questions as we've been going through our topic. So, usually during this time, we'd ask for Q&A. What we'll do is we'll collect any questions that come into the chat, and when we post our response video, anything that we didn't cover during the conversation, we will go ahead and do those. All right, Leo, why don't you walk us through how folks can connect with our team?
Yes. So if you do have additional questions about this tech talk, or if you want to know more about the topic, so we have a public Slack workspace. Our Slack workspace, it's Exadata dash database service. This is where we upload all our get started guides, how to demos, tech talk series replace, and also featured blogs. So we're inviting everyone. So we're inviting everyone to join our Slack channel. And on the next slide, so this is how you will join our Slack channel. So just click on the join link. And once you click on the join link, you just need to log in your email account for Slack, and then check your email, do your 2FA, and that's it. So welcome to our workspace.
Thank you very much for that. Thank you all for joining us on this edition of Tech Talk. Again, my name is Eddie Ambler, and my co-host is.
And I'm Leo Alvarado.
So we'll see you next time.